Who knows what a linear equation is? It's an equation that makes a line. So what do you think I mean when I say a system of linear equations? Many equations that make lines. Really, at least two. Two or more equations is a system of linear equations if they have the same variables. So we would define a system of linear equations as a set of linear equations, three, that have the same variables. Evidently. For example, if I had one equation that was y equals 3x plus 4, and I had another equation that was 2x minus 7y equals 12, that would be a system of linear equations. They're both linear, and they both use the same variables, which is x and y. So if I give you a system of linear equations like this, and I ask you to solve it, what am I talking about? What is a solution to a system of linear equations? Well, a solution to a system of linear equations the point or points that make all equations in a system true. So this is a fancy way of saying the point or points they share in a graph where do they intersect? Por ejemplo, God bless you, my child. If I were to create a graph with an x and a y axis, like this, and I were to draw two lines going across the graph. Here's one line. Let's go. You know what goes well with blue? Orange. You know, some people have said blue and orange are the two best colors. And by some people, I mean me. So here's my system of equations. This is line number 1. This is line number 2. And the spot that they have in common, the spot where these two lines intersect, right there, that is the solution. The solution is the spot where the two lines intersect, or if you're not graphing it, if you're just using equations, it is the x and y coordinate that the two equations have in common, meaning the x and y coordinate that is a solution for both equations. And we are, this week and next week, going to do this both ways. We are going to solve these by graphing, graph and find the coordinate where the two lines cross. And we are also going to solve this using algebra, just the two equations without the graphs. Okay, so let's take a look at the real world connection, the problem about the local community theater. I'll go ahead and jot it down real quick for those of you that are watching online. The local community theater sold 98 tickets the Sunday show, selling like hotcakes. Which my limited understanding is that hotcakes are a thing that you can sell a lot of. I mean, when I hear hotcakes, I think like pancakes. Is that what a hotcake is? And if it is, like, I mean, I think pancakes are okay, but I don't know that I would use them as a descriptive term for something that is very popular. Like pancakes are good, but I don't know that I'd say like, man, we sold so many of those things, it was like pancakes. Waffles are better than pancakes because when you put syrup on a pancake, your syrup just kind of goes everywhere. But in a waffle, it's like they have built-in syrup traps to keep your syrup right there on the pancake. Well, you got to get maple syrup. If you get like store-bought syrup, it tends to be really sugary. But if you go up to Vermont in the winter and crack open a tree and get that sweet, delicious maple, that's why we always holiday in Vermont in the wintertime, so that we can get the fresh maple syrup directly from the tree. Yeah, I also made all that up. I've never been to Vermont. I don't even know if Vermont has maple trees. And I don't like to go outside in the winter. But everything else I said is true. That's why I live in Texas, because I don't like the winter. So I picked a state that doesn't have winter. Okay. Yes, it has all the other seasons, summer and summer 2. And then we have the fall fake out and then summer 3. Okay. So this local theater sold 98 tickets to the show and they made $314.50. Adult tickets cost more than children's tickets. Adult tickets are $4, kids tickets are $1.50. How many tickets did we sell? Well, we can come up with a couple of equations here, which is good because to do a system of equations, we need a couple of equations. So first of all, we're going to define our variables. The question is how many adult tickets and how many children's tickets. Those are going to be our two variables, okay? So I'm going to say, that's a good idea. A is number of adult tickets sold. C is going to be the number of children's tickets sold. And then I can write two different equations here based on the information that I was given. One of the equations can be the 98 tickets that we sold. I sold a total of 98 tickets. Some of those were adult tickets, some of those were children's tickets. I don't know how many of each. That's the whole point of the question. How many did you sell? But I know if I took all of the adult tickets and all of the children's tickets and I counted how many there would be 98. So I can do the number of adult tickets, which was A, added to the number of children's tickets, which was C, should give me a total of 98 tickets. Right, you're telling me the second equation, which is going to be the amount of money I got from those tickets, $314.50. Some of that $314.50 came from the adult tickets and some came from the kids' tickets. And I don't know, again, how many of each I have, but I do know how much they cost. I know the adult tickets were $4 and I know the children's tickets were $1.50. So the equation I can write here is I take $4 and I multiply by the number of adult tickets. That will tell me how much money I made from adult tickets. Then I add that to $1.50. times however many children's tickets I sold. That will tell me the amount of money I made from children's tickets. And the total should be $314.50. Absolutely, putting 1.5 is a great plan, and I support it. Now let's assume, just for the sake of argument, that we had already graphed this. Okay, we're not going to focus too much on making the graph right now. I just want to focus on how to find the answer. So I'm going to go ahead and do an x-axis and a y-axis, and the bulk of my graph is going to be the first quadrant. Can you tell me why? Huh? Exactly. I cannot have a negative number of tickets. So it doesn't matter whether I do adults on the x-axis or children's on the x-axis. I'm putting children's on the x-axis just because. It's going to be the same no matter what. That's exactly right. So my first equation, a plus c equals 98. I wrote the equation in green, so I'm going to go ahead and do the line in green. And I'm just going to estimate. Do a very, very rough estimate. I'm going to say it looks kind of like this. It's going to have a y-intercept of 98. So I put the y-intercept up a little high. The slope's going to be -1. Again, we're not focusing too much on the line, how to graph it, because we've been doing that for a while. We're mostly just focused on how to find the solution. So then my second equation, let's say, looks kind of like this. And that is going to be the, oh, I did it in purple. Oh, no, that won't do. Consistency. Okay, so the second one was the 4a plus 150c equals 314.50. The solution to this system of equations is this spot right here where the two lines cross. And again, we're just doing introductions here. We're just learning the basics of systems of equations. So we're not going to worry too much about how to find that point yet, although it is coming. But I'm going to go ahead and tell you that it's 31.67. That is the point where those two intersect. I'm just going to tell you it's 31.67. What does that mean? 31 what and 67 what? How do you know 31 is the children's tickets and not the adult tickets? Exactly right. The first number is on the x-axis. Because I put children's tickets on the x-axis, the first number is children's tickets. I can check this by making sure that 67 plus 31 equals 98. It does. And then I could also plug them into the second equation to make sure the total equals $314.50. So the solution means 31 children's tickets and 67 adult tickets were sold for that Sunday show. If you go up to the 4a plus 150c equation and you replace the a with 67 and the c with 31, that will tell you how much money they made off of them. We made $268 off of adult tickets because that's 67 times 4. And we made the other $46.50 off of children's tickets because that's $1.50 times 31. So if I wanted to know how much money was made from adults and how much money was made from children, I'm guessing this is a show that is geared more towards adults than children, since it was mostly adults that went to it. And if it was a kid's show, we would expect maybe these numbers to be reversed. Yeah. So there's lots of adults going by themselves, and then some adults that had to drag their stinking children along with them, ruining date night. Okay, let's do another one of these problems involving money. So, Trent, okay. Trent has 9 coins that total 70 cents. Some are dimes and the rest are nickels. Say dimes and nickels only. Good. Good. So what Shelby's saying is we know it's not all dimes. Because if you had 9 coins and they were all dimes, it'd be 90 cents. And we also know it's not all nickels, because how much would 9 nickels be? Nickels are worth 5 cents. 9 times 5 is 45. So what's the first thing we do whenever we write an equation? That's exactly right. Define the variables. So if we know that all of his coins are nickels and dimes, those are going to be our 2 variables. How many dimes, how many nickels? So I think we should do N is the number of dimes and D should be the number of nickels. Who's with me? You're right, that'd be dumb. Let's not do that. D will be number of dimes. N is going to be number of nickels. I can use any letters I want to. X and Y are very common, but I like D and N. Okay, so I can write 2 equations now. The first equation I can write says that I have 9 coins. I don't know how many dimes and I don't know how many nickels, but I know if I take the number of dimes and the number of nickels and add them up, dimes plus nickels, I should have a total of 9 coins. The second equation I'm going to write is the one that tells me they have a total value of 70 cents. And this one's a little trickier. If I have all dimes, what would the formula be to find the value of just the dimes? How much is each dime worth? 10 cents. So 10 times the number of dimes will tell me the value of just the dimes. Nickel will be 5 times the number of nickels because it's 5 cents, and it will equal 70 cents. I could have done 0.10D plus 0.05N equals 0.70, but for God's sake, why would I put decimals in there if I don't have to? That just seems like the worst idea. Okay, so those are the 2 things that I'm going to graph. I am again going to do just the first quadrant because, as far as I know, you cannot have a negative amount of dimes or nickels in your hand. You could owe somebody dimes or nickels, I guess. Maybe that would be negative. It doesn't really matter whether you put dimes or nickels on the x-axis or the y-axis, so we'll just put number of nickels on the x. Fun fact, nickels not actually made out of nickel. Nickels aren't made out of nickel. But dimes are made out of dime. That's a fact. Okay. So again, we're not going to focus too much on the graphing because hopefully you're pretty decent at graphing by now. If you're not, your teacher owes you an apology. I mean, you're not going to get one from that guy, but he should apologize. So there we go. We'll do our first line. That'll be our D plus N equals 9. To graph this, we would just put it in slope-intercept form, and then graph it that way, which we've been doing for forever. And I'm guessing approximately right there would be the 10D plus 5N equals 70. And so, lo and behold, there is the solution. And it's 4, 5. Exactly right. What does that mean? Trent has 4 nickels and 5 dimes. Right, we can check that by saying, well, if he's got 4 nickels that are worth 5 cents each, that's 20 cents in nickels. Right. 5 dimes times 10 cents each is 50 cents in dimes. And 20 plus 50 equals 70 cents total. And he does have 9 coins. 4 nickels and 5 dimes is 9 coins. So the bulk of this is write the equations and then interpret where the 2 lines intersect. Tomorrow, we're going to get deeper into how you find the intersection. Let's jump ahead to, this is on page 8, Leon comparing the cost of 2 cell phone plans. So comparing 2 cell phone plans. So plan A charges $35 a month for unlimited talk. Oh, I forgot the group that I'm talking to. Kids, one of the apps that you have on your phone is called The Phone, and you can use that to actually call people and talk to them. It's like texting, but out loud, and nobody criticizes your spelling. It's like FaceTime, but without the video. Wow, that's dark. Plan B charges less. They charge $28 per month for unlimited talk. And 14 cents for each text message. Which plan is best? Now, the answer to that question is, it depends. The answer to the question is it depends on how many text messages I send. But what I can tell is, when are these 2 plans going to cost me the same amount of money? So we're going to write 2 different equations. One is going to be for plan A, and the other one's going to be for plan B. Okay, so let's go ahead and take a look at the first one. Plan A is $35 a month and 10 cents per text message. So can somebody help me write an equation there? Your answer should be no, because I haven't done the first step, which is what? What do I got to do before I write equations? Exactly, I have to define the variables. So let's say C is going to be the cost of the plan. What affects the cost of the plan? The number of texts I send. So how much is plan A going to cost me? It's $35 a month plus 10 cents per text. Would it be appropriate for me to put 10T? Why 0.10? Why won't 10 work? Right, $10 per text. I don't know if I ever want to send a text that bad. What about plan B? Somebody besides Shelby? No, sorry, Shelby, your name is Shelby. Somebody besides Shelby. Even the counselor can do it. This is algebra. Rowdy. What's the equation? Parker? Huh? Okay, 28 plus Julian, can you bail her out? Can you throw this at her? Very good, fake Julian. 0.14T. Your math is excellent. Your ability to follow directions leaves something to be desired. So if I were to graph this and find the intersection, what would it tell me? The intersection will tell me what? I'm not even going to tell you what the answer is. I want to know what's the answer going to tell me. When they will be the same. The intersection will tell me when, you know what, let's do even better than that. The answer will tell me the number of text messages that will cause the plans to cost the same. So if I send 0 text messages, like nope, no texting for me, phone calls only. If I send no text messages, which plan should I pick? Plan B. It's only $28 a month instead of $35. What if I'm like, okay, I'll limit myself to like 3 texts a month. Which plan should I pick? For 3 texts? 3 texts only cost me 14 cents each. That'd only be 42 cents in text. So instead of $28, it'd be $28.42, which is still cheaper than $35 a month. So if I'm only going to send 3 text messages a month, plan B is still better. What if I'm going to send 10 text messages a month? Well, let's see. Under Plan B, 10 text messages would cost me $1.40. 14 cents times 10 is $1.40. So instead of $28 a month, I would pay $29.40. Still cheaper than Plan A. What if I plan to send 19,000 text messages per month? Then I probably shouldn't own a cell phone because that's going to cost me a lot either way. But Plan A would be cheaper if I'm going to send 19,000 text messages. So somewhere between 10 and 19,000, we go from Plan B being the best to Plan A being the best. And what I want to know is, how many text messages is that? If I sign up for Plan B, how many text messages could I send before Plan A became a better idea? Maybe. I wonder if there's a way we can figure it out. And the answer is, of course there's a way I can figure it out. I'm going to open up my graphing calculator. So go ahead and navigate over to Desmos. Okay. I'm going to go to the graphing calculator. And I'm going to put in these two equations over here. So the first equation was, and I'm going to do y and x because that's what Desmos likes, y equals 35 plus 0.10x. And then I'm going to do the other plan, y equals 28 plus 0.14x. So there's Plan A and Plan B. You'll notice I can't actually see either one of those on the graph, and that's because the first one has a y-intercept of 35, and the second one has a y-intercept of 28, and my graph by default only goes up to 6, so I need to make my graph go higher. So I'm going to make my x go, I really don't need negatives, right? You're not going to send negative text messages. I'm going to make my x go from 0 to, I don't know, like 100. And I'm going to make my y go from 0 to, I have no idea how much my plan might cost. Let's go up to 100 there also. Yep. So it looks like these two lines are getting closer, right? But they're not intersecting. They look like they're about to intersect and then they don't. What does that tell me? But if I'm sending 100 text messages, Plan B is still cheaper because my graph went up to 100 on the x-axis, 100 text messages, and Plan B, which is the blue line, is still lower. So if I'm going to send 100 text messages or fewer, Plan B seems like a good idea. Let's go up to 200. If I change it to 200, now do the lines intersect? Nope, but they're getting really close. Let's go to 400. Still no. Let's go to 1,000. Oh my gosh, now it's hard to see because they're so close. Let's change our y to go from 400 to 1,000.
I think you need to change the x-axis
right, sorry,
to the
you're right.
y-axis to see
You're
it.
right, sorry. I was changing the wrong one, my bad. They're so close. So close I can barely see. Oh my gosh. Oh, look, there we go. You see the gray dot right there? Where the lines intersect? I put my mouse over there. 175 and 52.5. So I'm going to write that down real quick and then I'll go back to the notes. 175, comma, 52.5 is where those two lines intersect. That's my point. Okay. 175, 52.5. What does that number mean? Right, but what does 175 mean? if I send 175 text messages, both plans cost the same, which is $52.50. Now here's the important part. If I send fewer than 175 texts, which plan is better? Plan B is better. If I send greater than 175 texts, plan A is better. So this is a useful problem to me. Whenever it's time for me to sign up for a cell phone plan, I want a good cell phone plan, but I also want the one that's going to give me the cheapest service, right? If everything else is the same, if the networks are both equally good, if the data is both equally good, I want the one that costs less money. And sometimes you will get plans like this. Usually, I think most cell phone plans don't limit your number of text messages anymore. I think it's usually unlimited talk and text. And the thing that distinguishes them is the data. How much data do you get? So you got to think, well, this plan's cheaper, but I get less data. So what happens if I use more data? Would the overage charges for this plan still make it cheaper? You know, some of them are like, we'll give you 5 gigs of data, but if you go over, you're going to pay for them. But this other plan will give you 10 gigs of data, but it costs more every month. So you'd have to ask yourself, well, on the first plan, if the amount I pay for going over still makes it cheaper than the second plan, then it's better for me to get the 5 gigs and just go over every month than to pay for the one that gives me 10 gigs. Does anybody have any questions for me about systems of equations?